Alright, today we're going to do a lesson on graphing linear equations. This is going to be a review lesson to help you in solving systems of equations. So as a review of graphing linear equations, we're going to cover three methods. One, the table of values method. Two, the intercepts method. And three, the slope-intercept method. And then at the end, we're going to discuss on which method would be the best to use in different situations. Okay, so first off, let's talk about the table of values method. So with the table of values method, we take the equation that we want to graph and we choose values of x to substitute in and solve for corresponding values of y. So in this case, a good choice to use would be 0. And I would use that consistently when you're doing a table of values. And then you can just pick multiple other values. I'd choose a positive number, possibly a corresponding negative number, and you can grab a few more. Now really, you only need 2 points to graph a line, but it's better to have 3 or even 4 or 5 so you can verify that your points are all lining up in a line. And if you make a mistake, you can go back and try to correct that situation. So let's plug 0 in. We'd have y equals 3 times 0 plus 2. And 3 times 0 is 0. 0 plus 2 is 2. So our ordered pair is 0, 2. And then we'll plug in 2. So we have y equals 3 times 2 plus 2. 3 times 2 is 6. 6 plus 2 is 8. So we get the ordered pair 2, 8. Now let's plug in negative 2. 3 times a negative 2 is negative 6. Negative 6 plus 2 is negative 4. And so we have the ordered pair negative 2, negative 4. And we'll do this again for 3. And 3 times 3 is 9. 9 plus 2 is 11. So we'd have 3, 11. And last one, y equals 3 times a negative 3 plus 2. 3 times a negative 3 is negative 9. Negative 9 plus 2 is negative 7. And we get the ordered pair negative 3, negative 7. And now we can just plot these. So we go over to 0, 2, put a point. 2, 8. We go over 2, up 8, put our point. Negative 2, negative 4 is going to be over to the left 2 and down to negative 4. And we put our point. 3, 11. Now if you notice, so I go over 3, and 11 is actually off our graph paper. So I'm just going to estimate with a dot right here. Okay? And then we have negative 3, negative 7. Negative 3, negative 7. And as you can see, all these are lining up. So I'm not really concerned about this one. So I'm not even going to draw my line extended beyond that. I'm just going to connect these dots. And for the sake of time, I'm just drawing in this line. Please use a ruler or a straight line when you do that. And you can see that all of these do line up in a straight line. And now we'll go and do one more example. And again, I'm going to use 0. Now in this case, I see that I'm going to be multiplying by 2/3. So I'm going to choose values of x that are multiples of the denominator 3. And I'll show you what happens when you don't. So let's plug in 0. We're going to have y equals a negative 2/3 times 0 plus 6. Well, negative 2/3 times 0 is 0. 0 plus 6 is 6. And so we have an ordered pair of 0, 6. Now I'm going to plug in the 3. Two-thirds times 3, the 3's are going to cancel, and we have a negative 2 plus 6 is 4. And so we have 3, 4. And here we're going to have y equals a negative 2/3 times a negative 3 plus 6. Negative times negative is going to go positive. The 3's are going to cancel. And so we're going to have 2 plus 6 is 8. And so we have a negative 3, 8. So what if we chose a value that's not a multiple of 3, such as 5? Well, I'd have y equals a negative 2/3 times 5 plus 6. Well, in this case, the 5 and the 3 don't cancel. So you're going to have a negative 2 times 5 is negative 10/3 plus 6, and that just gets kind of ugly. So instead of doing 5 or some other number, choose multiples of the denominator, and that will make your life a little simple. For the sake of time, I'm not going to worry about this, and we're just going to plot these 3 points. So we're going to go 0, 6, 3, 4, and negative 3, 8. And I can see that these 3 are all lined up nice. And there's my line. Okay? All right. Now let's move to the intercepts method. The intercepts method is where we're trying to find where the line crosses the x-intercept and the y-intercept. To do this, we find the x-intercept by setting the y value equal to 0, because all ordered pairs on the x-axis, y is 0. And likewise, on the y-axis, x is equal to 0. So we come over here, and let's find the x-intercept, set y equal to 0. So we have 2x plus 3 times 0 equals 12. Well, 3 times 0, that just cancels itself out. And so we have 2x equals 12, and therefore x equals 6. So we come over here to x equals 6, put a point. Now let's get the y-intercept. Y-intercept, we set x equal to 0. So in this case, it's going to be 2 times 0 plus 3y equals 12. And again, we have a situation where 2 times 0 just goes to 0. So then we have 3y equals 12. And solving that for y, we get y equals 4. We come up here to y equals 4. We put our dot, and there we go, our line. Okay, one more example of using the intercepts method. Let's solve for the x-intercept, and when we solve for the x-intercept, we set y equal to 0, so this term goes away, and so we will be left with negative 3x equals negative 4. Divide both sides by a negative 3, and we get x equals a negative over negative is positive 4/3, which is equal to 1 1/3. Now let's do the y-intercept, and therefore we set x equal to 0, so then we're going to have 5y equals a negative 4. Divide both sides by 5. That negative didn't show up. And we get y equals a negative 4/5, or negative 1 1/5. Now, because these are fractions, they're going to be a little challenging to put over here on our coordinate plane, so we're just going to have to estimate a little bit. So our x-intercept is at y and 1/3, 1 and 1/3, and our y-intercept is at negative 1 and 1/5, so right about there. And then we connect our dots and extend it to show our line. So that's the intercept method. The last method we're going to talk about is the slope-intercept method. And with the slope-intercept method, you recall if your equation is in the form y equals mx plus b, the m is our slope and our b is our y-intercept. And we just got done talking about y-intercept. That's where it crosses the y-axis. So we come over here to our equation and we see that it's in y equals mx plus b form. It may not look like it because it's a subtraction here, but we can always write subtraction as y equals 2/3 x plus a -4. So in this case, our m is 2/3 and our b is -4. So we can go over to our graph and our y-intercept is at -4. And then we're going to go up 2 over 3, up 2 over 3. So that's what we do. 1, 2 over 1, 2, 3, put a dot. Up 1, 2 over 1, 2, 3, put a dot, and so on. And then you can connect the dots. Fairly simple. Just get your two values. One's your slope and one's your y-intercept. Let's do one more example here. In this case, here's our slope. M equals a -1 over 5. And here's our y-intercept, b, +3. So we go up to +3, put our point. Now in this case, it's a negative slope, so it's going to be down 1 over 5. 1, 2, 3, 4, 5. Down 1 over 1, 2, 3, 4, 5. And then we can connect the dots. When you've got equations that you're going to graph, you need to look at them and figure out what is the best situation, what is the best method to graph these. So using the table of values, I would say this is your last resort. Because it's math intensive and you got to choose values of x and plug them in and do that over and over, I would save this as your last resort. Or if you need to check certain values of x and plug them in. These two methods are going to be your primaries. When would you use intercept method versus the slope-intercept method? Well, you use the intercept method when your equation is in standard form, ax plus by equals c. You use the slope-intercept method when the equation is already in slope-intercept form. If it's not in slope-intercept form, but it's also not in standard form, you might need to rearrange it, okay? And I've got an example here. So if I had this equation, I would probably rearrange this and get it into slope-intercept method. Slope-intercept method tends to be my default, okay? So in this case, I just need to solve this for x. How would I do that? I would subtract 6 from both sides. So then I have 3y equals 4x minus 6. Then divide both sides by 3. And I would have y equals 4/3 x minus 6 over 3 reduces to 2. And now you can see you've got your slope of 4/3 and your y-intercept of -2. So that was a quick review of graphing linear equations. Good luck in your solving.